Alrighty, this one we get to start talking about series. So at the beginning of the notes, just so you guys know, I will put the types of series and the types of tests that we are going to have. So that way, if you're going through your notes and you're trying to figure out, hey, where was this? You can at least just like open the notes and you will see where we did everything. So the first one that we're going to talk about is geometric. And then we'll get to telescoping and the nth term test as we go through the video. So with the geometric, this is something that you covered in pre-cal. I know you did. So if I have something like 8 plus 4 plus 2 plus 1 plus 1/2 plus blah, blah, blah. This is also a big thing. Sorry. This is a series because it is a sum of terms, which means I will have a sub 1 plus a sub 2 plus a sub 3, so on and so forth. The last thing we were doing were sequences, and sequences are just a list of numbers. It is just like, I have this number, and then I have this number, and then I have this number. This series is actually taking the sum of all of my numbers in the sequence. Okay, so I'm telling you, this is geometric. This is geometric because as I go through each term, I am multiplying by 1/2. Eventually, this will get small enough, blah, 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 blah. I don't know what it's going to be. Probably not that number, but it's going to be over a huge number. So eventually, it will go to 0. So I'll eventually start adding nothing to it. So with infinite geometrics, I can say that it actually is some number. I can say it goes to a sum. And I can say the sum converges to the sum of an infinite is my initial term, so a initial, over 1 minus the rate. That is how I will find the sum. However, let's say I have 8 plus 16 plus 32 plus 64 plus blah, 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 blah. All right, eventually, I'm just going to start adding huge numbers. And even once I think I've gotten to a sum, I'm going to add an even bigger number to that. So notice in the first one, my sequence, or the individual terms, do eventually converge to 0. This one, they diverge away from all known numbers, and they go to infinity, so this series would diverge altogether. But this is the kind of condition that we need. You also need to understand how it is stated in sigma form. It has some term or not, that could be just 1, but I am able to write a rate to some n power. You knew it is n minus 1 in pre-cal, but it doesn't have to be n minus 1, could be n plus 1, could just be n, doesn't make a difference. But as long as we can get it to some power, then I can find my rate. All right, so the first one here, find the sum of each series if it converges. So first thing I'm going to ask myself is, usually, does it go to 0? And if I think about 1 over 2 to the n, then that's just going to get a bigger and bigger and bigger denominator. Like essentially if I put in infinity there, that's going to be 1 over infinity, so that will go to 0. That's going to be eventually our nth term test for divergence, but we'll get there. And I would choose to rewrite this using my rules of exponents. Make this 1 over 2 to the n, because that n will apply to the 1 as well as the 2, and this allows me to see my rate much more easily. So the other thing, like we talked about, as long as the numbers are getting smaller, I can find a sum. This other one, the rate was 2. I was doubling it. So a big thing with geometrics is they only converge if and only if the absolute value of the rate is less than 1. That is going to be a part of our statement as well. Okay, so here I have a rate of 1/2, and if I want to find the sum, it's going to be my first term over 1 minus the rate. So my first term is when I plug in 3, so I have 1/8 over 1 minus the rate, which is 1/2. And let's see, I have 1/8 over 1/2 then, so 2 over 8 is 1 over 4. So what I'm going to say is, since the series, I'll just say the series, is geometric, with r equal to 1/2 which is less than 1, the series converges to 1/4. Right? And by stating the series, as long as I state the word series there, that is telling the sum of the numbers. So I don't have to state the series converges and the sum is 1/4. That's kind of redundant to me. But you do need to state all of this stuff. You need to say this series in particular is geometric. I need to state the ratio is 1/2, and I know that is important because I need to know that it is less than 1. Then I can say that this series converges to 1/4. So there's not much that I can take out of that. I guess if you want to take out the sense, cool, but I'll probably still write it. Okay, so that's it. That's all we're going to be looking for on that. This one, this does not have an nth power. And as I look at my terms as they go out forever, that's 1 over infinity and 1 over infinity, so they will go to 0, so I might be able to find it. So let's just write out the terms. I mean, they're supposed to go to infinity, but I can't really think about putting infinity in, right? Because I would go to nothing, so I don't know how to find the sum. Well, let's write out for some nth sum. So with this nth sum, my last term is going to be the a sub n term. Well, if I do the first term, that would be 1 over 1 minus 1 over 2. And then the second term would be 1 over 2 minus 1 over 3. That's interesting. And then the third term would be 1 over 3 minus 1 over 4. Okay, so check this out, right? Negative 1/2, positive 1/2, negative 1/3, positive 1/3. Then I bet negative 1/4, positive 1/4. So let's see, let's think about as we go out to my nth term. I'm going to get up to it. I'm going to start with my a sub n minus 2 term. So if I put in n minus 2, this is 1 over n minus 2 minus 1 over n minus 1. Right, and I'm putting it still into, this is my rule to find the sum. And then I'm going to find my plus a subscript n minus 1. So 1 over n minus 1 plus 1 over, not plus, what are you doing? Minus. 1 over n plus, here's my a sub nth, or my last term, 1 over n minus 1 over n plus 1. All right, so looking at my last terms too, negative 1 over n minus 1 plus 1 over n minus 1 will subtract out. Negative 1 over n and plus 1 over n will subtract out. So I bet this 1 over n minus 2 subtracted out with the term on the left-hand side there. So this series, the sum, can actually be simplified into 1 minus 1 over n plus 1, which is pretty cool because now I'm trying to figure out what this infinite sum is. That is my goal. So this sum, as it goes to infinity, should be just 1. Because if I put an infinity there, right, that's 1 over infinity, which will go to nothing. So all I'm left with is that 1 there. So that's it. So this sum converges, and its sum is 1. I found it. We did it. Right? This is called a telescoping sequence. I guess they call it a telescoping because it's like an extended telescope. If you extend it all the way out and then you can kind of collapse it to a smaller thing. That's my guess. I don't know. But it's called a telescoping. We don't have to state it's a telescoping. But in my statement, I'm going to say since the limit as n approaches infinity of s of n is 1, the series converges to 1. And that's it. Question was asked in class a lot, why do I have to have that term? It's going to go to 0, right? It will. But my explanation for this and why I can't just ignore it is because this is the nth sum. So really, truly, if I wanted to find the 10th partial sum, that would be the sum of the first 10 terms, and it would be 1 minus 1/11. So until I write this limit part of the sum, I can't get rid of that term. And from my understanding, they do like to see this statement. And I don't want you to get caught up in a multiple choice in case they say, this series can be simplified as which sum? And they list it as an nth sum. I want you to know where those second terms are coming from. Okay, moving on. This too is a telescoping sequence. Reason I know, or I hope, is because of my denominator. And that's all we've covered so far. We haven't covered anything else other than telescoping or geometric. So let's use our partial fraction decomposition and hope that one of these come out as a subtraction. All right, so I have 6a n plus 2 plus bn. So let's try to make a come out. So to get rid of b, n is 0, and a will be 3. When n is negative 2, that will get rid of my a, and b will be negative 3. Perfect. That's a 3 or something like that. All right, so then this sum from 1 to infinity is 3 over n minus 3 over n plus 2. Right, and I think the shortcut for these telescoping is you will have as many terms as the denominators are off. So if we look in the last one, the denominators were off by 1 term, so I kind of had 1 term on either side. So the other thing too here is if you have straight multiple, you can factor that out to make this become 3 times the sum from 1 to infinity of 1 over n minus 1 over n plus 2. So using my trick, I'm going to say that the sum is 1 plus 1/2 minus 1 over n plus 1 minus 1 over n plus 2. That's how it should come out. But let's list it, right? Because I want to figure out, this is my s of n, right? So s of n, if I put in 1, I get 1 minus 1/3 plus 1/2 minus 1/4 plus 1/3 minus 1/5, and that's all I'm going to write in the positive direction, like moving forward from the beginning, because I now notice that I will subtract out that 1/3 right there. So most likely my 1/4 will subtract out with my next term, which it has to, which means I'll be able to subtract out the 1/5. So we are right in assuming that I can have 1 plus 1/2. Now looking at the end, to figure out which the end terms are, I usually write out as many terms at the end as I write in the beginning. So in this last one, really truly all I would have needed were 2 terms, so I probably would have only written these 2 terms. I was just trying to help you guys kind of see what was going on with those middle terms as well. But you don't have to write them. And really truly, I don't think they're super looking for this part, but they will be looking for this. All right, and then I have plus, I'm going to go 2 terms back, so n minus 2. So 1 over n minus 2 plus 1 over n, not plus, it's a minus, plus 1 over n minus 1 minus 1 over n plus 1, and then plus 1 over n minus 1 over n plus 2. Because now I can see that my 1 over n's will subtract out, which means I will be able to get rid of the first terms as I go backwards. So I am indeed left with negative 1 over n plus 1 and negative 1 over n plus 2. So I think that shortcut will work, but I do like to kind of verify it with this as well, just thinking about those terms. So then what I can do is say, since the limit as n approaches infinity of s of n equals, so now here's the thing we need to remember too. I factored out a 3. So really, I want to figure out, hey, 3 times that limit. Well, the limit itself, this will be 0, this will be 0. The limit itself will be 1 plus 1/2, which is 2 over 2 plus 1 over 2, so 3 halves. So if I multiply that by 3, then that is 9 halves. And this just allows me to tell that the sum of the original series is 9 over 2. So since this limit converges to 9 halves, the series converges to 9 over 2. And that's it. That's what I'm looking for in the statement. So the limit equals 9/2. I define, make sure you define what S of n is, otherwise you need to do it in your statement, and the series converges to that sum as well. All right, looking forward. So this one, I noticed some n's in the exponent, so I'm thinking geometric. It is 5/3, so maybe if it's geometric, this isn't going to converge. But let's take a look and try to rewrite this in a little bit more clear of a way. Right, this would be 5 times 5 to the first times 5 to the n over 3 to the n. Right, and all that allows me to do, since 1 plus n is 1 plus n, right, that's how those would combine by my exponent rules. So n equals 1 to infinity of 5 times 5/3 to the nth power. And this tells me that the rate is 5/3, which tells me I'm done with this problem. Because I can say, since the series is geometric, with my ratio equaling 5/3, which I need to state why that is important. It is important because it is bigger than 1. The series diverges. And that's it. Alrighty. With this one, not geometric, not telescoping. So the next thing I go to, and really the only thing we have left right now, but one of the first things I think about is, what is my nth term going to go to? So the nth term test, so the only thing that is good for is telling whether something diverges. That is it. That is the only thing that I can use it for. There are sequences that converge to 0 that are actually divergent series. So with this, essentially, if my nth term does not go to 0, then it diverges. There's no option, right? If I'm adding 1, like if my limit goes to 1, then I'm adding 1 over and over and over again. If I think the sum is 6, then I'll add 1 again and get 7, then I'll add 1 again and get 8, so on and so forth, right? So if this is true, if it does not equal 0, then I have to diverge by the nth term test. You need to state what test you are using as well. Because by the end of this chapter, we will have 10 of them in our back pocket to use. So what I would say is I would personally predefine this as a sub n, right? So that is calling this a sub n. I'm trying to equate that for my reader. You could also say let a sub n equal 4n plus 1 over 3n minus 1. Either way you want to do that, makes no difference to me. But I need to then say, since the limit as n approaches infinity of a sub n is 4 over 3, right, by our horizontal asymptote type deal, 4 over 3, which is important because it is not equal to 0, the series diverges by the nth term test. And that's it, right? So again, we need to state why, what, and by what test. So it diverges because the limit does not equal 0 by that test. They're looking for all three things there. All right, moving on if my iPad will let me. All right, this one, there's a couple ways to look at that, but I kind of want to show you a unique way to look at this. But it looks like probably maybe this is going to go to 1 or something like that. If I set up my limit, I could do L'Hopital's, right? Because if I set up the limit with this, I would get e to the n over e to the n plus 1. And then I would get e to the n over e to the n plus 1. And then e to the n over e to the n plus 1, so on and so forth, right? So it would never end if I just kept doing L'Hopital's the entire time. So really my issue is the n's. If I can make those n's go away, because right now it's just infinity over infinity, which is indeterminate, and I think I can make it go away by multiplying by e to the negative n. So if I do it to the bottom, I must do it to the top. Because what it does in the bottom is this n and this n plus 1 will subtract out so that my denominator is just e, right? because negative n and positive n makes 0, so that is just e to the first. Now with these terms, n minus n will make e to the 0, which is 1, and then multiply e to the negative n by 1, so plus e to the negative n, which is 1 over e to the n. And now if I say that this equals 0, infinity, a sub n, because now if I put in infinities, this is the only place I'm putting in an infinity, and this is 1 over infinity, which is 0. So this is 1 plus 0 over e. So this limit, so since the limit as n approaches infinity, yikes, of a sub n is 1 over e, which does not equal 0, the series diverges by the nth term test. Right, cool. That's it. All right, last thing that we are going to get into is just recognizing these as geometric series. Really, that's all these decimals are. So if I have 0.7 repeating, that is 0.777777777, right, as many times as you want to write it across your page. But this can also be represented as, since there are 7 tenths, right, that's that part, plus 7 hundredths, that's the next one, plus 7 thousandths, that's the next one, plus 7 10,000ths, so on and so forth. I think I actually had a student that's going to UCLA contact me recently. He's in a Cal 2 or Cal 3 class, and he had one a little bit harder than this, but was asked to write this as a ratio of 2 integers. And because he was in my number sense, he knew the trick, but this is stuff that, for whatever reason, they like to ask sometimes. But the whole recognition here is realizing that our ratio is 1/10. It's multiplying by 1/10 each time. So if I wanted to write this as a series, so n equals 1 to infinity, and it's 1/10 to the n times 7. Right? This could have also been written as like n equals 0 to the infinity, 7 times 1/10 to the n plus 1. This could have also been written as n equals 2 to infinity, 7 times 1/10 to the n minus 1. So just think about the exponents on these things. We can write these really infinitely many ways. Usually we're not going to start on the -1th term or something like that. I've never really seen them do that. So I don't think that is a thing, but I don't know. I could be wrong. I wouldn't see why it couldn't be a thing, but I've just never seen it. So yeah, there's just lots of different ways. So if there's a multiple choice, just make sure if the first way you list it isn't there, try to pay attention to the bounds and what they're doing with where they're putting in the series. Okay, so now how do I write this as a sum of 2 integers? Well, the infinite sum of this thing is the first term, so 7/10 over 1 minus the rate, which is 1/10. So if I do that, that's 7/10 over 9/10, which is coming out as 7 over 9. Type it in your calculator, and I bet it's 0.7 repeating. Okie doke, 0.19. So a little bit different, but just think about this, right? It's repeating every 2. So this is really 19 over 100 plus 19 over 10,000 plus 19 over, what's next? A million? 3, 4, 5, 6. Yeah, a million. And so on and so forth, right? So my ratio is 1 over 100, right? Because it's every 2 that it is happening. So my series, 1 to infinity, so 19 times my rate, 1/100th to the nth power, right? It could have also been 1/10 to the 2n or something like that, but it's all about how you write it. A sum of 2 integers, or a fraction of 2 integers, ratio of 2 integers, that's the word I was looking for, 19 over 100 minus 1 over 100, which will come out as 19 over 100 over 99 over 100, which will come out as 19 over 99. And that's it. All right, hopefully this was helpful. Sorry it was so long. Well, I guess it's not terribly long. But I'll stop talking. All right. Talk to y'all soon. Bye!